Hello dear students, in this video I will start with the term 2 syllabus of Unit 4 Calculus, and it consists of limits, continuity and finding the derivatives. In term 1 Calculus, you must have studied about functions, then different types of functions, domain and range of a function and graphical representation of a function. Here we will see the remaining topics of Unit 4, which is Calculus, and the first topic is limits. First we will see what are limits. Now consider the function f of x equal to x square. If we observe, as x takes values very close to 0, then the value of f of x also moves to 0. And we can symbolically write this as limit x tends to 0, f of x is equal to 0. So in general, if we want to know the definition of limit of a function, it is given by as x tends to a and f of x tends to limit L, then here L is called the limit of the function f of x, and it is symbolically written as limit x tends to a, f of x equal to L, or this L is called the limiting value of f of x as x tends to a. Now we will understand this with an example. Find the limit of f of x equal to 4x as x approaches 3. Now if you want to find the limit of f of x as x approaches here 3, we can do this as limit x tends to 3, f of x equal to limit x tends to 3, 4x. Here in place of x we have to substitute 3. So we get 4 into 3, which is 12. So as x approaches 3, f of x will approach 12. That is the meaning of limit. Now moving on to the algebra of limits. The first one, the limit of a sum is the sum of the limits. That is limit x tends to a, f plus g of x is limit x tends to a, f of x plus limit x tends to a, g of x. And then the limit of a product is the product of the limits. That is limit x tends to a, f into g of x is limit x tends to a, f of x into limit x tends to a, g of x. Then the limit of a quotient is the quotient of the limits. That is limit x tends to a, f by g of x is equal to limit x tends to a, f of x upon limit x tends to a, g of x. If both limits on the right hand side exist and are finite, and the limit in the denominator is not 0, this limit should not be equal to 0. If that is the case, then limit x tends to a, f by g of x is equal to limit x tends to a, f of x upon limit x tends to a, g of x. In the next video, we will discuss about left hand limits, then what is right hand limit and all those things. Here we will solve the questions from the Check Your Progress 5 of chapter 8 from the CBSE book. First one, find limit x tends to a, 8 minus 3x plus 12x square. Limit x tends to 2. Now limit x tends to 2, 8 minus 3x plus 12x square. It is equal to 8 minus 3 into 2 plus 12 into 2 square. So it is 8 minus 6 plus 12 into 4, 48. So this is equal to 50. So limit x tends to 2, 8 minus 3x plus 12x square is 50. Next question, find limit z tends to 8, 2z squared minus 17z plus 8 upon 8 minus z. Here if we substitute z as 8 directly, we will get the denominator as 0 and the function will become not defined. So here we have to factorize the numerator first. Now limit z tends to 8, 2z squared minus 17z plus 8 upon 8 minus z. This is equal to limit z tends to 8, 2z square. We can factorize this as, so it is 2z squared minus 16z minus z plus 8 upon 8 minus z. So this is equal to limit z tends to 8, This 8 minus z, I am removing the minus sign and writing it as z minus 8. So here we have 2z into 2z minus 8 minus 1 into z minus 8. 2z into z minus 8. So this is equal to limit z tends to 8 minus of 2z minus 1 into z minus 8 upon z minus 8. Now these two will go. Now we can substitute 8 here. So it is minus of 2 into 8 minus 1. So it is equal to 16 minus 1, which is minus 15. So limit z tends to 8, this function is equal to minus 15. Now these are some additional problems which I have taken from the NCERT textbook for practice. Evaluate the following limits. Limit x tends to 3, x plus 3. This is very easy. This is equal to 3 plus 3, which is 6. Next question, limit x tends to pi, x minus 22 by 7. Now limit x tends to pi, x minus 22 by 7. This is equal to pi minus 22 by 7. If we substitute pi as 22 by 7, we get this limit as 0. This is for pi equal to 22 by 7. Next question, limit r tends to 1, pi r square. Here limit r tends to 1, pi r square equal to pi into 1 square, which is equal to pi. Next question, limit x tends to minus 4, 4x plus 3 upon x minus 2. Here limit x tends to minus 4, 4x plus 3 upon x minus 2. This is equal to 4 into minus 4 plus 3 upon minus 4 minus 2. So this is equal to minus 16 plus 3 is minus 13 upon minus 6. So this is 13 upon 6. Next question, limit x tends to minus 1, x raised to 10 plus x raised to 5 plus 1 upon x minus 1. So here we can substitute x equal to minus 1 and find the answer. So this is equal to minus 1 the whole raised to 10 plus minus 1 the whole raised to 5 plus 1 upon minus 1 minus 1. So this is 1 minus 1 plus 1 upon minus 2. So this is equal to minus half. Next question, limit x tends to 2, 3x square minus x minus 10 upon x square minus 4. Here if we substitute x as 2 directly, here the denominator will become 0. So what we have to do is we have to factorize the numerator and remove the factor x minus 2. Here limit x tends to 2, 3x square minus x minus 10 upon x square minus 4. This is equal to limit x tends to 2, 3x square. This minus x we can write it as minus 6x plus 5x minus 10 upon x square minus 4. Now this is equal to limit x tends to 2, 3x into x minus 2 plus 5 into x minus 2 upon this x square minus 4 we can write it as x plus 2 into x minus 2. Now this is equal to limit x tends to 2, 3x plus 5 into x minus 2 upon x plus 2 into x minus 2. Now these two x minus 2 will go. Now we can put x as 2 here. So we get 3 into 2, 6 plus 5, 11 upon 4. So, limit x tends to 2, 3x square minus x minus 10 upon x square minus 4 is 11 by 4. The next question, limit x tends to minus 2, 1 by x plus half upon x plus 2. Now this again we cannot write x directly. So first let us simplify this. So this is equal to limit x tends to minus 2. Here the LCM is 2x. So we have 2 plus x upon 2x upon x plus 2. This is equal to limit x tends to minus 2, x plus 2 upon 2x into x plus 2. Now x plus 2 will cancel. Now this is equal to minus 1 by 4. Next question, limit z tends to 1, z raised to 1 by 3 minus 1 upon z raised to 1 by 6 minus 1. Here again we cannot substitute z as 1. So here again we have to factorize the numerator. So limit z tends to 1, z raised to 1 by 3 minus 1 upon z raised to 1 by 6 minus 1. This z raised to 1 by 3 we can write it as z raised to 1 by 6 the whole square. So this is equal to z raised to 1 by 6 the whole square minus 1 square. Now this is of the form a square minus b square. So we can use a plus b into a minus b formula. So it becomes z raised to 1 by 6 minus 1 into z raised to 1 by 6 plus 1 upon z raised to 1 by 6 minus 1. Now these two will go. These two will go. Now we can apply the limits. So we get 1 plus 1 which is 2. So limit z tends to 1, z raised to 1 by 3 minus 1 upon z raised to 1 by 6 minus 1. It is equal to 2. I hope this video was useful for you. Thank you for watching.